Hey, I'm going to do some 2-6 problems with you, for you, about, no, not about you, that's the wrong preposition there, but with. Let's go with that. So, what are we doing here? We're doing 17 through 39 oddsies, so you got a chance to check all your answers already. Here's the deal. I'm going to shortcut a lot of these problems, and I'm going to tell you how I'm going to do that and why I'm going to do that. So there's really two ways of understanding this. If you look at these problems where you got limit as x approaches 0 of, we know that sine x over x, that's 1. That's what we got from the squeeze theorem, or sandwich theorem, whichever we called that. And if you have something like this, sine of, let's say, ax, there's some number in front of the x there, over b, so the coefficients are not just 1. Well, that's equal to just a over b. And here's why. I can't remember exactly how much I went into this in the notes, so sorry if this is repeating. So if I put an ax on the bottom, an a on the bottom, well, I can do that, but I have to put an a on the top too. That's just multiplying by 1. And then I rearrange things. Sine ax over a, that's just 1, because these things are going to be marching over x, sorry. You do an a over a, and what am I messing up here? I want that to be an x on the bottom. Oh, because this would be over bx. That's why I'm messing that up. There we go. Okay, sorry about that. Sorry for the confusion. Okay, so if I can get these things to match up, the ax over ax, then that's just also going to go to 1. As long as it's going to 0, if x is going to 0, well then ax is going to 0 too. So this turns into a 1, and then if you have ax over bx, well that's just highest power, top and bottom is 1, so that's equal to a over b. And then doing similar tricks to this, it turns out that if you have the limit as x approaches 0 of sine x, sine of ax, or sine of tangent x, or just tangent ax, or just ax by itself over any combination of sine of bx or tangent of bx or just bx by itself. Any combination, any one of these things over n of any one of these things is just a over b. And I'm not going to keep going through this process every time for those. So, okay, now that we have that under our belts, let's jump in. Number 17. And number 17, can't use that trick. So we've got the limit as x approaches positive infinity, cosine 1 over x. This is one of those composite type things where I think I just need to figure out what's going on in here first. So if x is going to positive infinity, 1 over that is going to 0, and the cosine of 0 is equal to 1. That's all. That's all you need to do. All right, so 19, the limit as x approaches positive infinity of the sine inverse x over 1 minus 2x. Okay, as x approaches infinity, what's going on in here? Highest power, top and bottom is 1, so I've got coefficients are 1 over negative 2. So this is going to negative 1/2. So that just turns into, well, what's the sine inverse of negative 1/2? I don't know how you think about this, but you need to be able to pop that out of your brain pretty quick without a calculator. So real quick thought process for me would be sine is all about y coordinates. So this is a y coordinate. So if this is the unit circle here, then a y coordinate of -1/2 puts me here. Now sine inverse, we're looking for an angle that's in between -π/2 and π/2, and that is going to be -π/6 right there. So you need to be able to do that. All right, here we go. Now I can use my trick here. So sine, I got 3 theta over theta. That's 3. And that's because it was just this over this. One of those. Number 23. Sine theta over theta squared. Okay, you got to be careful here. So the limit as theta approaches 0 from the positive side. So I'm going to split that up. That's sine theta over theta times an extra 1 over theta. All right, so I split up the theta squared. This is just 1, but this 1 over 0 is infinity, and I'm going to the positive side. So that's 1 times positive infinity, and that's what we get there. Number 25, I can use my trick because it's just tangent something x over sine something x, so it's just the coefficients, which is 7/3. Number 27, so that's the limit as x approaches 0 from the positive side. I've got sine x over the square root of x, and then there's a 5 down there. I can just leave that in there. And so I want this to be like sine x over x. This is like the wrong power. So here, instead of splitting things up, I'm going to multiply by square root of x over square root of x so that I can get that to be x on the bottom. So now I've got sine x over x. That's equal to 1. And then I have the square root of 0 over 5. So that's 0. So I'm going to get 0 there. Number 29. Got sine of x squared over x. I'd like to be that. I'd like to be that. I wouldn't like to be that. Would you like to be that? I don't think I'd like to be that. I would like that to be an x squared on the bottom. So I'm going to multiply by x over x, and that is going to turn that into now this. Those match up, so that's equal to 1, and then I have an x here that's going to 0, so that just goes to 0. Let's see. We are at 31. Let's squeeze some more in here. Where are we going to 39? Oh, we're this home stretch. This is a quick one. 31. Let's see what we can do with this here. Limit as theta approaches 0. So I got theta squared, sorry, oh no, this is t, I was looking at 33. T approaches 0, so I got a t squared on the top and 1 minus cosine squared t on the bottom. I'm going to factor that. That's 1 minus cosine t times 1 plus cosine t. And I'm also going to take that t squared and split it up like this. Because I know that this, one of the things that we got from the notes for 2/6 is that this is equal to 1. Now if you're looking at this saying, wait, that's upside down. Well, 1 upside down is still 1. So we're good there. So this is equal to 1 times, when I plug 0 in this, I get 0 over 2 So that's equal to 0. So that whole thing is just going to be equal to 0. Wait a minute. Hold on a sec. Oh, wait a minute. Boy, I messed that up. Because, and the reason that I messed that up is because this is not the thing that is, hold on a second, think about that. T that is equal to, do not like what I have done here. I'm supposed to be getting 1, which you probably know, and I can see how I can do that, but I'm trying to figure out why is it that what I have done here is wrong. So, oh, I know why. Sorry. Because this right here, from the notes, sorry about this. Confusion. That's not equal to 1. That's equal to 0. And you can't have that upside down because that is infinity. So you get infinity times 0 there, which is a big old question mark. Don't know what infinity times 0 is. So that's no good. All right, so where do we go with this one then? Well, we noticed that because sine squared plus cosine squared of theta or whatever is equal to 1, well, if you subtracted this to the other side, then 1 minus cosine squared is equal to sine squared. And then we're good, because I just have 2 of those. So that's the same as the limit as t approaches 0 of t over sine t times t over sine t. So this is 1, and this is 1, and 1 times 1 is 1. There we go. Sorry about that. And how about 33? Let's see. So this is kind of similar situation, maybe. I think I have thetas this time. Sorry, theta approaching 0. And I've got the theta squared on the top and 1 minus cosine theta on the bottom. Because you might think, oh, maybe that has something to do with this. Well, maybe, but even if I could get it to look like that, if I split that up, it's still going to be upside down of this, which is going to give me an infinity here, which might not be so helpful. So maybe there's some other trig kind of thing that we could do, and maybe we could be inspired by this. So what if I multiplied the top and bottom by 1 plus cosine theta? Because that will turn into this, and then it could be possibly in good shape from there. So then, let's see, I would like to keep that theta squared with these, because then I'll end up with the same situation as number 31. So I got theta squared over 1 minus cosine squared theta, which is the same as sine squared theta. And then I've got one extra one of these, right? This all turned into the same as what we did in 31. And then I've got my extra 1 plus cosine theta. So this turns into a 1, and then plugging 0 in here, cosine of 0 is 1. So that gives me 2 there. A little tricky. All right, back to composite type things. Limit as x approaches 0 from the positive side of sine of 1 over x. So that's going to, as 0 as x approaches 0 from the positive side, this is going to go to infinity. And the sine of infinity, well, the sine function is forever bobbing up and down between 1 and -1. It doesn't actually get closer and closer to anything. It's trapped there, but it's not approaching something. So this is solid does not exist. It's bouncing back and forth between 1 and -1, but does not approach either one of those. So you would have to say the limit does not exist. Number 37. This is another little tricky one. I'll show you what you have to do here. If you didn't see this, if you didn't realize that this is the thing that you needed to do, then, oh geez, I wouldn't feel bad about it. This is tricky. So that 2 up there on the top, I'm going to break up into like a 1 plus 1. And one of the ones I'm going to put there, and the other one I'm going to put here. And then, because I know about fractions and stuff, I'm going to just split those up. I mean, common denominator, right? So you could add those together, and that would turn back into the original problem. And this expression here, this is true even if there's a constant here. That still works just fine. It's still equal to 0. So this is equal to 0 plus 0, and 0 plus 0 is equal to 0. That's that. And last one, 39. Oh, I already told you, we did this. It's just A over B. That's what we talked about at the top. That's our little trick. And that always works because of what I told you before. That's a good trick to know. And that's it. Hey, that's not bad. 17 minutes. Cool.